our lab. We both belong to a lab called LCS2, Laboratory for Computational Social Systems. We mostly work in 5 verticals, although these verticals are not completely disjoint. Our major focus is on exploring different cyber informatics, cyber security aspects in online social network, including fake news, hate speech, cyberbullying, collusion, etc. We also work on complex networks, graph mining, where we look at social network, social graph, information network, and so on, and try to answer questions like how influential nodes are, how information diffuses over time, etc. We also work on in core NLP. We work on conversational dialogues and text summarization. In multimodal and low resource languages, we are also interested in exploring all this this fake news, hate speech activities, mostly in Indian languages, and we also do some works on multimodality. So until recent years, there had long been a stance by Mark Zuckerberg that Facebook was platforms. Facebook was just a platforms rather than publishers, right? Therefore, are not responsible for content that is published on their platform. We all saw last year where how Zuckerberg was encountered by US Senate to present the role of Facebook to stop spreading fake news. And we also know the incident of Cambridge Analytica in 2016 US presidential election, right? So in the current climate where COVID-19 pandemic conspiracy theories are on the rise and radical injustice is being played out on the world stage, Facebook and Twitter's founders have increasingly responsible to moderate such content. Both Twitter and Facebook have been removing posts that promote violence, suspending accounts for repetitive hate content, and highlighting manipulated photographs and videos. However, even by the time of their action, most of the damage is usually done. So therefore, we need technologies to spot hate speech and fake news as early as possible to stop spreading such social media pollution. I call them social media pollution, and the users responsible for this pollution are called content polluters on social media. So in this tutorial, we'll present many such cutting-edge solutions that help curb fake news and hate speech on social media. At the end of the day, we hope that the audience will have a handful of ideas about state-of-the-art solutions devised in recent years to tackle the problems of hate speech and fake news. So this is the outline of the tutorial. So the tutorial is divided into 2 parts. The first part is going to be presented by Shad, where we mostly describe different tools and techniques for fake news detection, for claim identification, for claim verification, and existing data sets and methods. Then we'll take a break for around 20 to 30 minutes. And the next part will be presented by me, where I will mostly discuss about some recent work on detection of hate speech and how hate speech and fake news diffuse over social media, mostly understanding the dynamics from complex networks point of view. So without further ado, I would like to ask Shad to start the first session. So the most of the content that we are going to present here are part of this book that I have co-authored recently. So if you want to know more about the content that we will present, you possibly want to look at this book in more details. So Shad, you may want to start.
Yeah, thank you, Dr. Tanmoy. So maybe you can start.
Yeah,
stop sharing your screen.
Yes. And the audience, please feel free to interrupt us at any point in time, because otherwise it will be boring. So please interrupt us and feel free to ask any question. Thanks.
Okay. So can you see my screen?
Yes.
Okay.
Yep.
So good morning to all of you. So as Dr. Tanmoy just described what we are going to do in today's session. So first session, I'll be talking about fake news and claims. And in particular, my main focus would be on claim detection and verification. What are the different works that had been done in this particular research area, and how this claim we can relate it to a fake news. And in the later part, we'll also discuss, once we identify there is a statement which has some claim in it, can we verify it, and what are the different research works and recent research work are there to solve this particular problem. And possibly at the end, I'll also talk about, I'll give in some existing annotated corpus with respect to this claim detection and verification. And probably you can take up those data set and those problem for your own research. All right, so starting with this outline, as I just mentioned, fake news, claim detection, claim verification, and possibly the future. So first, let's define what is fake news, and it is very intuitive to know what a fake news means, and it is something which is posted to with false narrative, right? A news which is not real, a news whose veracity is not established, and possibly this is a false message. But the main thing that keep this fake news apart from any other thing is that its intention. Fake news is always related to the malicious intent. The person who posts this fake news or the organization who posts this news, their intention to take some advantage, right? And these advantage comes in different form. It can be a political advantage, it can be financial, it can be some other regional advantage as well. And the reason that they do is that in order to get this advantage, there's no direct path for it. So they could have done this through a legal path, but that takes lots of time. So using fake news, they're trying to create a narrative which helps their cause. And they want to do it very, very quickly. Another side effect of this fake news is that it can lead to a loss of lives and loss of monetary values. So this makes a fake news a very, very important problem with respect to our society, as well as the life we live, the world we live in, where everyone is kind of obsessed with the social media side, and whatever news we see, whatever posts we see on Twitter, Facebook, and other platforms, we tends to believe them blindly without verifying those claims and verifying those news whether they are correct or not. And there we know that there are lots of incidents that happened in the recent past. Uh, so just to give you an example, so this particular meme or news where someone is claiming that FBI agent who was part of Hillary Clinton is founded because he did something to expose Hillary Clinton for some malicious activity. But this news was again termed as a fake news. In recent times, with respect to this pandemic and COVID thing, there are different kinds of claim and different kinds of news that we have seen in the recent past, and lots of them are actually fake. For example, this particular news is with they're claiming that WHO claim that asymptomatic patients do not spread COVID-19. So they're using some credible sources to post this. But the person who posted there, he himself is not a credible person, right? So it is always difficult to identify whatever news you are reading or whatever news you came across, whether this particular news, whatever claim it makes, it has some real content or not, right? So this is quoting, this particular tool is quoting WHO, who is known to be a credible source. Similarly, again, there's another example with respect to COVID thing. So Bharat Biotech will be taking first roles, of course. So here, this particular tweet is also giving you some visual uh, clue that something is happening, but this tweet is again found to be fake tweet. Now, with respect to these three different kinds of posts that we have seen, it is very, very difficult to identify without having world knowledge, without having actual knowledge is what's going on with particular topic, right? For example, the second tweet that I mentioned in WHO. So there was some press conference going on, and in that press conference, one of the WHO representative actually narrated something which is related to asymptomatic patients. But the way that people took that particular claim or narrative is that they make that particular claim into a false claim. The main issue was the asymptomatic person do not show symptoms, and it is rare or slightly less likely that they will spread some COVID-19. Though there's some bit of truth in it, but the way that this particular statement was twisted and posted and retweeted again and again, at the end it becomes completely fake. So it's talking no, they're not talking in terms of less likely or less probable. They're just saying they cannot spread COVID-19. All right. So we have seen different kinds of fake news, and they're very, very different. They can be posted at it up to you how you want to interpret that particular phrasing. For example, in this case, the one particular news headline says Ramdev Patanjali Ayurvedic claims it can cure COVID-19 in 7 days. Now, what kinds of fake news you are looking for? What kind of content we should examine whether this is a fake or real? So given this particular example, you may ask yourself, is it Patanjali did not claim that's the fake, that's the real? So you can say that the content, the fake content is the Patanjali did not claim this. That's the fake part. Or you can also claim, no, Patanjali actually claims something, but it's not that it is, they can cure COVID-19 in 7 days, probably in 70 days or 6 months, something like that, right? So it is very difficult to know what kind of fake news we should look into or what kind of exact content we should focus into. And another example I can show you here is that which is referring to ICMR study. So India to witness COVID-19 peak in mid-November. And they're referring this statement from ICMR study. Now, but by looking at this particular statement, most of us will believe that since ICMR is a very, very trusted source, and so whatever news or whatever content they generate, there seems to be legitimate, right? But things comes out, this particular statement comes out of a fake. However, you have to look back into the what happened during this period where ICMR, whether there is a study which claims this COVID-19 peak in mid-November as a real or not. So it turns out the information is there on the internet, but the claim that made this viral is that they twisted that claim, or whatever claim or evidences they show for this particular statement, they are not credible itself. So the backstory of this particular news is that yes, there was a study done, and yes, there were some researchers who were part of the ICMR study, ICMR, but whatever they did, whatever paper they wrote and they posted in an archive, that they posted in a preprint version. And that preprint version was not verified. Nobody reviewed that paper, nobody did review of that particular work. So in one sense, you can quote that evidence. Yes, there is a paper exists. If you look on the Google, you can find a paper which says this COVID-19 peak in mid-November. But they don't have their like ICMR authority on that particular news. And later, when this particular statement become viral, ICMR has to come out and they have to publicly say that yes, these two researchers are part of our study, but this is still in the preliminary phase, and nobody reviewed that paper. And finally, they just discarded this claim completely. So it is very, very difficult to identify a fake news without having such a context, without having proper knowledge of it. All right.
May I ask you a question?
Yes, sure.
Sorry for interruption. Fake news, are you concerned with about the text only or video or audio or mixing?
So recent research, they take everything, right? They in social media posts, textual contents are there. Some fake news we can see with respect to some sharing a video. Some fake news is with respect to only text and only image. So if you look back at this particular slides, you can see that the first case is the simple text, which is giving you some idea whether this is a fake or not. The image is not exactly part of the statement. There's just some random image, or you can say that. There's information is this whether this particular image gives you a fake information. It's not like that. They're just trying to relate this FBI agent and it will help you. However, in the second case, they're giving a
Yes.
video, and this
Yeah, it is
video
received.
contains that particular statement from this WHO correspondent, and they twisted this in the actual form. So
Video
what
is
we can,
a challenging task.
right, definitely it's a challenging. So they also, in many cases, you can see that they give some references as well, right? So in case of ICMR, in case of this WHO, they're giving some links, they're giving some
Right, 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 right.
resources to prove that this information is actually correct. But in the life we live in, we are very, very busy, and very less people actually go and check those links properly and look at the Google, what are the different information they can find with respect to this particular topic, right? So,
Right.
and I was like, first view, you can always tend to believe the story if you have some links, and these links are credible links, right? So you are
Right.
quoting WHO, you are quoting ISMR. Yeah, so it's
Okay, okay,
very, very
okay.
difficult, right? All right. So by looking at this few example, it is very, very difficult to know what exactly fake news is. And though we have in briefly defined fake news as a malicious intent and intent, it post with a intent to create false narrative to take some advantage. But different researchers, different experts come up with different views and different explanation of that. So some of these are this. So fake news is the manipulate of public opinion to manipulate public opinion. Its intention is to mislead people. Its intention is to passing misinformation, passing rumors, or deliberately causing some cause. So there are different views, different definitions on the fake news, but we can say that we all use these definitions are correct with respect to fake news, and it totally depends on like, what's the purpose, what's the intention of the person who is actually posting this kind of fake news, a person or organization. Yes. So, on its like general sense, we know what a fake news. It has to be malicious intent. It is spread to take some undue advantages. That's the very basic definition we can give with respect to this fake news. All right. So next, since we know what is fake news and what can be the adverse effect of this fake news, and the adverse effect is so huge that it can cost some human lives, right? And so nothing can be worse than this, taking someone's life, right? So this fake news, a simple fake news who a person posted with the comfort of his home, with the comfort of his office, just one line statement will cause people to lose their lives, right? And they can cause people to like actually create some violence, right? And lots of other stuff, right? So there's three examples that you can say. Two of them are inclined towards loss of human life. Another is the conspiracy with 5G towers. This is related to monetary value, right? So it has a huge effect, and we have to do something with respect to this fake news, right? So timely information detection and taking a preemptive action is very, very much required. It's a need of the hour. We cannot just turn our face away from this. So with this fake news and the effects, another issue that we can normally come across are these fake news posted by humans only? Can we say that? Whatever intention we have, uh, is there any person or people who's sitting behind this creation of this fake news? And the answer is no. We all know that, and this is has to do with the technological development in the bot, right? So we have lots of bot which can create these fake news. You give some idea, you give some topic and narrative to this fake bot, and these bots will actually generate fake news for you. And that's just pretty scary, right? So what kind of, we know what's GPT-3 and GPT-2 are capable of doing, right? They can generate some text which is very, very close to, it is very difficult to disambiguate whether this has been written by a human or this has been written by a particular bot. So creating a false story with malicious intent, which can have huge adverse effect, And this all thing is no manual intervention is required. It's very automatic. They can create like very fast. So these things are scary. So it turns out, a study says that from, I think it's from ICWSM paper, that 9 to 5% of Twitter accounts are actually bots. And we know how much Twitter accounts are there, right? So it's a significant number. So almost out, out of like 85% are human, and they're not very, very active. Some users are very active, some are slightly less active, but 15% is a big number, right? And imagine what they can create if all of them are used for creating fake news or for malicious purpose. The adverse effect will be huge. Another study says that Instagram itself has almost 95 million bots, and they're posting content with as a real agent, real accounts, right? So again, this is a scary thing to do. So you don't know where, when you see an Instagram post. Probably, I'm just giving you an example. Have the telegram, it's not exactly the same. Probably for your Amitabh Bachchan, Shah Rukh Khan, or some other celebrity or some politician, you don't know. You never know whether there is a bot sitting behind that particular Instagram account, or there's an actual person who is posting these things. Right? It's very difficult to know. And the second question we can ask, that let's assume that, okay, whatever content we are seeing, and so how do we make sure the content is credible? So we may ask, second is that, can we blindly trust the post of verified user and organization? So far, the narrative of the research or narrative of the people is that fake news and malicious story always comes with a malicious account. Right? So the account which has not been verified or which is very unknown accounts. So only fake, those account can create or post fake news. But it's not exactly the case. Sometimes what happens, especially with respect to fake news and claims kind of thing, so a credible person such as Elon Musk, who is a very verified user, very well-known person in the world, second richest person in the world, and he tweeted this back in March 2020 with respect to this COVID. And whatever claim he made, he didn't give any reference for that. And the statement that he made is actually very, very difficult to digest, right? So kids are essentially immune, but elderly with existing condition are vulnerable. Though there can be some truth in it, but the claim that it makes, this particular tweet makes, it's very, very intensive, right? You are just undermining the effect of or the threat of COVID for a kid. So people who believe in blindly believe in animals, they can say, okay, kids are essentially immune, so we don't have to worry with respect to kids. But later in the study, we know that WHO itself comes with this. COVID is like a threat to every person on the planet, right? So the information that you read from verified account, they can also be fake, and we have to take preventive measure to detect these accounts or these contents in a timely fashion, such that their effect should be as minimized as possible. Moving forward, so I'll just give you a brief study of this fake news detection, because my main focus would be on the claim detection for verification part. So with respect to this fake news, there are majorly three kinds of studies we can find on in the literature, right? So content-based fake news detection, fake news detection in social context, and how a fake news propagates through time. So these are the different work that you can see. If you are interested, you can look into the details. So some of them only take like considering the content of the tweet or content of the post for detection of fake news, and they did different kind of stuff. They have to go in the back end and get some evidences and try to check this news with respect to evidences. Similarly, in the social context, how what is the effect of a person who is or the account from which this fake news are getting posted. So it is studies on that line. The third is that once this fake news occurs on the internet, what is the effect of this fake news? How they quickly spread through the network and something like that. Right? And some study also, which is recent study in 2019, that it takes everything into account. It takes the content, it also studies how fake news propagates. It is working within a social context. So different kinds of studies you can find in with respect to fake news. So if you're interested, you can go and look at these papers.
Uh, I think social context, that means you willing to mean the source of the generation of the fake news.
The source of the and the person who created this news, whether there is some relation with the account, Twitter account or Facebook account, and the kind of content they generate.
That
So if
means
a fake account is there, so it's
news, it may be fakes. The source of the news is Kolkata, but someone generated from USA. Like this, no?
no. So what I meant from here is that the account from which this fake news were posted, right? User profiles. So if you look
Oh,
and
okay,
look at this
okay,
user profiles and metadata of that user, so these
okay,
kind of things, and
okay,
also like some images, some text, some videos. So everything comes under this.
okay, okay, okay.
All right. So uh, moving ahead, uh, since this is a big thing and we all know that, so what researchers are doing, they're trying to develop different kinds of mechanism to combat these fake news. But at the same time, big corporation like WhatsApp, Facebook, Twitter, they all are doing something with respect to this fake news and hate speech as well. So they're trying to come with new ideas, new constraint to uh, identify fake news as quickly as possible, and they try to prevent this news for in spreading, right? So WhatsApp recently imposed some forwarding limit that okay, you cannot post or you cannot forward a particular post to this many people. So this is mainly with respect to the propagation of fake news, right? They did not actually post it like what is a fake news, what is not, but they did their bit that they are allowing a people to forward a particular post with very limited number of people. That means this particular fake news will take some time to reach to a global mass. Similarly, Facebook, they are doing their bit, like, and they're taking some action with respect to fake account. And these are the number that you can show in the past 4 years, right? So in like different quarters, these amounts in quarter of 2019, they have taken action on more than 2 billion accounts, fake accounts, right? So you can just see. So they are also limiting whenever they detect a fake account, they are deleting that. They are restricting a particular account to be created if they sense that there's something malicious information has been provided to Facebook. So this is with respect to Facebook. With respect to Twitter, when a person tweets something, and this is very recent, November 2020. So Twitter is actually tagging this tweet with respect to its dubious content, right? So we all know that this recent US election with Joe Biden and this Donald Trump, Biden won lots of majority of the states and majority of the seats. Still, Donald Trump says no, I won the election, and you Twitter come up with this tag that official sources call this election differently. That means the, whatever content this particular tweet says, it is different version what we can get from official sources. So they're doing their bit, right? But still we have miles to go, and the reasons are very very clear, right? So fake news and especially fake news as such, which is very difficult to know without having a proper context, without having a proper domain knowledge, right? So since we have recently seen there lots of works have been going on for the past picture, and there are lots of misinformation were posted online and they're spread online, and existing system failed miserably because we didn't have a knowledge base, we didn't have proper domain knowledge which can verify whatever the claim has been made, whether it's true or not. So for every new topic you need lots of resources to which can be taken as evidence, right? That's the one challenge we have. Second challenge that we have when we have this knowledge is to create these kind of knowledge which you need human intervention, right? So what are the reliable sources, whether the evidences that you're calling, whether that evidence is credible evidence or not. So there are lots of human moderator in between to decide this the content of fake news or the evidences, right? So various fact agencies that are existing today, Snoops.com, Boomland, etc., etc. they have lots of moderator. Even in a recent study, Facebook themselves introduced almost 10,000 human moderator for moderating the content on Facebook. They are manually looking the content which is dubious and malicious, and they are tagging this. Okay, this is a fake news. This is something. So human intervention is very much required, and this make this particular fake news detection pretty difficult, right? It's very non-trivial for that. So one thing we can see on the internet is that fake news is always related to some claims, right? Whenever you say something, the news, the content that you want to express, it has some claim in it, right? So fake news and claims are very, very strongly correlated, right? A news with a claim, you can always ask yourself, whatever the claim this particular news is making or claiming, whether it can be a fake news. So in that sense, we can say that whenever you see a claim in any statement, any post, that is worthy of a fake news detection problem, right? So you always think, well, whatever content the claim this particular tweet makes, whether it's a fake or not. So in this respect, these two has a very, very strong relationship. But the difference here is that fake news, as we talked about earlier, so it is always ill intention. So it's malicious intent and always aimed at causing some harm. Right? Harm in respect to monetary or some other things, right? However, claims may not be ill intention. So you just, if a claim is true, that can be true. So if I say something, let's say I say something, there has been accident and these many people died at some spot, that claim may not be true, right? So it totally depends on the situation. But if this is a claim, then we can easily say whether or not this is a fake news. So what we are trying to do here with respect to claim and fake news here, we are narrowing down our search space for a fake news detection. So this table give an example for that. So there are four text is here, and you can see that the first two texts defines give some claims, right? They claim something. The first is alcohol cures corona. So that's a claim. If by drinking alcohol you can cure corona. The second claim is that wearing masks can prevent corona, right? So these two statements are claims, and the later two statements are, they're not claims, they're actually opinions, right? So this claim is not reflecting a societal sentiment, rather there is a personal interpretation, right? So you can easily see at these two columns, claim and fake, what is the relationship. Fake is always those statement which has some claim in it. So if we can easily identify, okay, whatever news is there, it's not a claim, then it's very unlikely that this can be a fake, right? So with that respect, recent work, we starting this claim started with the argument mining. Now people are exploring claims with respect to fake news as well. How claim verification and claim detection we can do with respect to fake news. All right. So the next portion of this talk will be focus on claims and claim detection and verification and other stuff. Now let's talk about what claim is exactly. What is the definition of claim? So definition of claim is that a statement or assertion that something is true without giving proper evidence. Right? You can say anything, you are not able to provide any proof for that. So that's the claim, right? I can claim that sun rises in the west. So from our general knowledge, from our world knowledge, we can see that this statement seems to be false, but I'm claiming something, right? Without giving any proof. So that's what claims we can. And always, everywhere, whenever a fake news happens, these claims are very highly associated with it. So in first example, that Elon Musk's example that we have seen earlier, the claim is that kids are essentially immune. That's the claim. And that's the claim Elon Musk is claiming for, right? That's the information. Similarly, in the other example, there are other claims. So if we can easily detect these claims and we can narrow down our search for a fake news detection, so the detection part or the human effort or the manual effort that we need, they are slightly reduced. So that's the main objective of these research with respect to claim and fake news. All right. So once we have claims, so you can ask, yeah, so it's okay, we can identify claim, then we can go for the fact checking, right? But claim detection itself is a challenging task, right? Because of this opinions. And opinions are the personal interpretation, and it's very, very specific to the person. So if I say that dogs aren't that great, it's my personal opinion. This does not reflect any social convention, right? But the other true claims, which is very, very specific, which has some societal effects, these are claims. However, the difference or the main trouble comes into the picture when there are opinionated claims. So if you look at this particular statement, I think the Chinese stole a bioweapon, sent it to Wuhan, China. It got somehow they cover. We know all this COVID and Wuhan, China, right? So though this is an opinion kind of, but they are claiming something, right? They're saying claiming that Chinese stole a bioweapon. So this statement is both. It is has opinion, also it has some claim. So identifying a check-worthy claim is difficult, right? So we need to know what's the difference between claims opinion and what is the opinionated claims. And this makes difficult for machine to decipher, right? That's where the challenges comes into the picture for the detection part. All right. Moving ahead, let's see some of the research on claim detection. We'll start with the very beginning, argument mining. So claim detection in argument mining, then we build upon that, and recent works with does claim detection techniques for the fact checkworthiness. All right, so this is probably the one of the first papers on claimed identification in online discussion. This has been proposed in 2012, so it's quite old, almost 8 years, 8 or 9 years back. And this particular work is very, very naive and very simple. It's a very feature-based classification using logistic regression, and they use some limited set of features, and these features not very extensive or disaster, right? So they have these four set of features, where first is the whether some sentiments are there or not, or some ratio and count and blah blah blah. These kind of sentiments features they've used. Also, they propose that whenever there is a question in a statement, that is very unlikely to be a claim. So they use this particular feature to identify non-claim statement, right? So absence of question mark is a worthy candidate of claims. That's another feature. And then traditional lexical feature, parts tagging, n-gram feature they use. And finally, they use some social media features like some metadata and some other like hashtags and others, orthographic features they have used for the as feature for the logistic regression classification. And the result that they show is that there's extensive result, and there are lots of other results you can see, and they did lots of application study to come up with. And the data set that they use is that these two data sets, which they came up with, Live Journal and Wikipedia data set, and the distribution of data set is 197 as a claim and 791 as a non-claim in Live Journal, and so almost similar in the Wikipedia data set. And the best accuracy they achieve is like something like 82.82 with respect to unbalanced data set, right? And they also tried with the balanced approach where the number of claims and non-claims are equal, so they reduce the down sample the claim sample, and they achieve almost 76% of best accuracy that they can get. This is a very preliminary and very first approach on this claim detection. The next paper on this claim detection is actually context independent, and there is an argument within argumentative statement, and they're trying to find the claims in it, right? And for this, they develop a kernel-based approach. So this key kernel they use in SVM classification to identify the claims. But rather than as compared to the previous approach, which solely depends on the unigrams and some other feature, textual features, they actually think from a different perspective. They said that no, in order to identify a claim, structural information is very, very much required. and there is a pattern that you can find. Okay, this claims has this pattern in the structural formation, that's the consistency tree, and this paper actually exploits that property. So as a very like stepwise method, this particular work does something. They split it into sentences. They created consistency tree for all the statements that they have, and they discarded those sentences which does not have a verb phrase, right? So their heuristic is that whatever feature they're taking for the claim identification, they're considering there should be a verb phrase in it, and that verb phrase is actually give you clue for it being a claim or not. From this, with respect to this verb phrase heuristic, they created some partial subtrace that was taken from consistency. I'll talk about in the next slide how to come up with this partial subtrace. And they train SVM with tree kernel, right? And tree kernel is they try to match the overlap between two statements, consistency true of two statements, with how much similarity these two sentence have with respect to its constituency tree. That's what they did. So for to give you an example, the first figure shows two constituency path tree, and these two constituency path tree have some claim in it. So the statement is a significant number of Republican asserts that hereditary monarchy is unfair and unjust. So this part of the S bar is actually the claim, right? The second statement says that critics believe that regulation of online gambling is a better alternative. Again, this S bar part is a claim, right? So what they did in with respect to these two statements, that they identify or overlapping structure of these two constituencies. So all the nodes in this box, it is appearing in both this consistency tree. So you can see that this VP, VVZ is. So this also there, VP, VVZ and is. Similarly, S2, NP and VP, this is also available in this. So they identified all the overlapping structure within this subtree. Once they identified this, what they did is that they captured some subtrees with respect to this overlapping uh, non-terminals, right? So for example, for this part of this subtree, that VP is unfair illicit and is a better alternative, you can see that. So they have extracted some partial tree. So they've extracted VP to VBZ as a feature, so it's prevalent in both this here and here, right? Similarly, VP, VBC, and this way they have generated different uh, path tree, and these path tree is actually the input of this kernels, that tree kernel that they did, and they just map how many overlapping structures are there, and the more the number is, the better the chances that these two statements are the claim statements, and they identified with respect to that probability. So for this particular work, they have this was done with IBM research. So they have created this 90 as essays, and there's other data set that they have created on their own. And the result is they shown is that whenever you use tree kernel with a topic, what's topic with the claim topic, you get a decent job. It's not the 100% correct output, for the with respect to precision at 20. So the best output that you can get is 19.6. The main drawback of this work is that it does, though it incorporates the structure information of the sentence, but this structure capturation is very, very nice. It just overlap, nothing else. They don't regard what kind of a structure, what kind of constituents of this subtree. Whenever there is non-terminal overlapping with the other statement, they take it as a match. Right? So this was the one initial work with respect to claim detection using structured information or structure of the sentence. Moving forward, there's another work which is unsupervised, and they also use some heuristic based on the structure of the sentence. And in this, particular work, what the author did is that they said that whenever a statement that comes into the statement, it is very likely that this statement is going to be there. So in that sense, if a statement which does not have that, they did not consider that. That's the rule they have used in this unsupervised claim detection thing. So what they did is that given a sentence, they created a claim sentence query, right? And this claim sentence query has three parts in it. First is the presence of that. That should be present in that sentence. And after that, within that statement, they identified which is the main concept. And this main concept is nothing but a topic which has a Wikipedia page. So a named entity which has a Wikipedia page. That's a very simple concept they did. And based on this Wikipedia, they've accessed lots of resources from that, lots of evidences from that. And after this main concept, they also created a claim lexicon, a list of words that has high correlation with being a claim or not. And this claim lexicon they have created by using this Wikipedia title that they got from the main concept. And how they did is that they identified the suffixes in a sentence that is followed by that and the main concept. So whatever words are after that, and after this that, if there is a main concept, so all words till the end, they are taken those tokens in the claim lexicon. Okay. So you can see that here. So they've classified all the statements in two classes, C1 and C2, in which they say that, and please remember that both this C1 and C2 contains a sentence which has a word that, but the difference is that C1 has MC just after that, right? So that's the definition of C1 and C2. And CT is a statement which has that, but MC, that main concept, does not immediately follow this particular word that. And based on this, they have come up with this probability, and this probability is nothing but N1 is the number of sentences for which this word W belongs to C1 class, and N2 is the number of sentences for which W belongs to C2 class. So that's the probability they've computed. And if a word with respect to C1, all the word that is suffixed in a sentence after that in MC, if the probability is higher than the prior probability of the class C1, then they have taken this word into the claim lexicon.
Hello, sir.
Yes.
Sir, I have a question.
Yes, please.
So here, this is again a rule-based system, is it?
Right. This unsupervised, this is rule based. They only talked about the statement which has that in it. That's the very first limitation of this book.
Fine. So finding the word and then applying the rule in that way.
Right.
Okay. Thank you.
So this way they have created this main concept and claim lexicon. And once they have this, did some ranking mechanism. So whatever sentences they have, they've computed a score, and that score actually gives the ranking of the sentence. And in order to compute this ranking, they use these two uh, method. So first method is the what-to-wick cosine similarity, and for this they have computed the vector representation of each word in the sentence, followed by that to the main concept. What is the cosine similarity of each word in the sentence with the main concept word? Second measure that they take is the number of token between that and the first match of the claim lexicon. So this boundary, they say this is the part of the claim. Based on this, these two scores, they average it out and they rank all the sentences. Whatever sentence has higher score, they say this is the most relevant statement, and a phrase which starts at that till the end of the sentence, that is the claim phrase. That part is claim, they say that. excuse me. Though they have also mentioned that this particular extracting claim boundaries are very, very narrow, some other techniques, supervised technique, can also be applied to identify the end of the claim boundary. Start, we know, whenever there is a statement that is the start of the claim. And when this claim is actually ending, that you can use some supervised learning to detect. But since this method is unsupervised, they went with this simple rule that whatever till comes till the end, that particular phase will be part of the claim. So that's how they have detected claims. Excuse me. All right, so this particular work they've used on Wikipedia, May 2015 done, which has more than 4.5 million articles. And they showed this results on the development set, test set, and this levy is one of the prior work on this claim detection from the same authors. Okay, then they showed some improvement over the previous attempt. The limitation of this work is one that it is very, very biased towards that if a statement, a claim which does not have that, for example, kids are immune to coronavirus, that statement does not have that in it. So this work will not be able to handle that scenario. That's the first of them. Second limitation is that this particular work cannot handle multiple concepts. That is a statement which has more than one claim with respect to different concepts. So all this talk about a single concept. That single concept is the main that MC thing, right? The named entity which has some Wikipedia pages. And obviously, because of these reasons, this cannot be used for exhaustive set of claims. That means it cannot be used for every claims that are present on the internet. Right? So these are some of the limitations of this one. All right. So another work in 2017, and this is basically not a very much research-oriented paper. Rather, it's a very engineering approach kind of thing. So what they did is that they come up with different sources. They collected data from different sources. So in total, they have used 6 different data sets. All these data sets have different structure or different property from others. So this one is the online comment, another is simple micro text. This particular various genres has different statements, simply web discourse where there are lots of user queries and user responses are there, Wikipedia talk pages, some processive essays that has been written. So all these different kind of data set they have combined together in order to do 2 sets of experiments. One is in domain and another is cross domain. The basic objective of this particular paper is that if we have data set for one particular domain, can we use it for detecting claim in another domain? That's the very engineering approach that they did not introduce new research direction or new objective. Their only objective is that how we can handle this in domain and cross domain scenarios. So for this, they've used some features, and for these features, simple lexical orthography feature, lower unigram, position, length, punctuation. Though they have said this as a structure features in the paper, I have just named it as the orthographic feature. Then there's some other features as well. Other is that this parse tree and part of the speech tags they have used as a syntax feature. They've used discourse feature, some embedding, word embedding they've used. And finally, they have experimented with different version of this feature set. So they've tried with different class of the feature. They've tried with different all the features, also dropping of some features, some ablation studies are there. And for modeling this particular work, they have used simple convolutional neural network, LSTM, and BiLSTM. And within convolutional neural network, they tried 2 versions. The first version is that where they have initialized their vectors from Google News word embedding. And another is where they have just used random vectors without initializing anything. They use random initialization and trust on their network to learn these embeddings. And they've given lots of exhaustive results. So they tried lots of different stuff. So So you can see from this table is that these are in-domain experiment. That means if you look at this empty microtext dataset, so train and tested on both microtext, right? Similarly, for every other dataset, they have reported, and finally the average one. They also, the main objective of this, how this particular feature, these set of features and the method that they use, how they can behave in cross domains, where they've trained on one and tested on other. So you can see from here is that, so the source, the number of rows where you can see that empty rows, open comment, on this data set, they trained their model and they tested on this, right? So for the first row, for example, is for CNN random version. And here the model was trained on microtext and they evaluated on all these different data sets. So how this performs. So this is the overall idea. So in some cases, they have observed that data set is kind of giving the more or less similar result. In some cases, the better result than the in-domain experiment. But in majority of case, they have identified that in-domain experiment, which is very much they are working better, and that was not very surprising, right? So in-domain always works better, and cross-domain we go for cross-domain when we don't have sufficient data to train our models, right? At the cost of some lesser performance. All right, so next, this is another paper, and relatively it's recent because it's a 2019 paper. And this particular paper is again more inclined towards engineering approach rather than some research oriented how claims are doing. So their objective is again how they can utilize the lack of leverage the abundance of data in one domain for training of a classifier for claim detection in another domain. So for that, they have used this ULM fit architecture, where they train one architecture on a general domain language modeling. Then they have transferred learning this to fine-tune language model on the target domain or the target task, the claim detection task. So this first block is irrespective of the task. We don't have any task defined here. This is just a general domain language model. But the second task is more specific to the data with respect to the claim detection. Okay? And finally, whatever weights they have learned through these two steps, they transferred those weights to for learning a claim detection classifier. So that's what their overall, that's what their approach was. So for doing that, they have developed this IMHO data set, and this data set actually is very naive, you can say, again not very qualitative, but still there lots of statements are there. So the first set of data set that they use is self-level opinion data set. That's the IMHO data set that we talk about, and they have collected almost more than 5.5 million sentences from Reddit. And what they did is that in that Reddit comments, they filtered all those statements which does not have IMHO or IMO. That means in my opinion or in my honest opinion, right? So for example, they have taken this statement where there is a IMO or IMHO. So IMO Lakers are in big trouble next couple of years. So this is part of the data set, and this is a claim, right? So they have identified whenever there's IMHO and IMO are there, these are opinionated claims. So that's what their bias was. So using this technique, you can easily observe that there is no negative sample. That means this particular Reddit data set does not have any statement which is not a claim. So everything that is there, the statements are there, their claims. Also, for the this transfer learning approach, what they did, they utilized this existing publicly available labeled corpus for claim detection. The first is this microtext, which is originally in German, but the English version is also existing. And most of the research that you have seen previously, they use at least one of them we discussed, and there are lots of other research work which utilizes this English version of MT. And you can see some of the data set statistics for this. All right. Excuse me. So this is the result that they showed. So after having this transfer learning ULM fit architecture, they've reported results for with respect to training on WD, and then transfer learning with respect to this IMHO data set, and fine tune their model for this. And these are the different numbers that you can get. So as I mentioned, this is a very like experimental kind of approach rather than very research oriented approach. Okay. All right. So moving forward, this is one of the recent direction in this claim detection thing. So this year, CLEF 2020 challenge was established, and this within that workshop, there is a task called claim detection and check worthiness estimation for COVID-19 tools. So here now we are looking towards claims and fake news. So the idea is whether there is a claim or not, and if that is a claim, we have to estimate the check worthiness. So whether we have to go for verify or find the veracity of these claims or not. So since the domain of this particular challenge was COVID-19, and back then we didn't have lots of resources, so you can see the number of tweets for this data set is only 962. So it is very small number comparison to the other data set that we have, not in claim detection, but other domains, other tasks. And we normally know that deep learning techniques usually works better when we have sufficient number or good number of training data annotated samples. Similar in this line, or I may say that CLIF 2020 uh, is the second step of this claim detection part. In CLIF 18 or 19, they are also conducted this workshop, but there they have only focused on claim detection in different domains. But here they have also included a check worthiness estimation. So if you are interested, you can look at these workshop papers or the workshop task, and you can easily get data set for that. And these are some of the summaries of the claim detection dataset that are available, especially the 6 dataset that cross-domain works actually uses. And these are the references, genres, and number of docs and the claims. One important thing you can see here is that the number of sentences in these datasets are, we would not say this is very huge, but rather is sufficient number, right? They're not very huge. Excuse me. And another thing is that within that number of sentences, the number of claims you can see. So the at max you have 30% of claims in possessive AC dataset. That means out of 7,000, you only have 2,000 claims. And even though this W Wikipedia talk pages are 9,000 sentences, it only has 1,000 claims. So you can clearly see the unbalanced structure of the dataset. Right? All dataset are imbalanced, right? So number of claims, and which is very true with respect to claim, hate, or fake. So it is very difficult to find a tweet, a verified tweet, which is actually a claim, actually a fake news or hate speech. It's difficult to get those information. Right? All right. Now we'll move towards claim verification. So these works have discussed about the detection part only. Now we are moving towards claim verification. So first thing, what do we mean by claim verification? So the definition is that given a claim, you have to verify its veracity. That means you have to confirm whether the claim which is in front of you is a true, or you reject that claim as a false, or you don't have sufficient evidence or sufficient information to say that whether it's true or false. So you say it is unverified, we don't know that, it's still to be resolved. That's the three possibility outcome of this claim verification part. So you can see that people have tried with ternary classification or binary classification. You only go with true and false, or you can go with true, false, and unverified. And this unverified is very important. This does not mean that the whatever claim you are dealing with, they are false or true. You don't know. You say, I don't know. That's the information, right? So that's claim verification, the task as a task we have. Now you can ask, since we have detection claims, we know the input is the claim. How can we go forward for the claim verification? And this is actually a difficult part. Detection is slightly easier because still that's a classification problem, right? But here you need evidences for a claim to be true, false, or unverified, right? So the normal pipeline, and this is adopted from the Zubega et al. In 2017 paper. So a normal pipeline of fake news detection or claim detection is that you have a claim detection. First step is that, right? So you say, okay, yes or no. If it is a claim, yes, you have to track some, or you have to get some evidences. So that's called claim tracking. So you look for on the internet, you collect lots of sentences, lots of those with respect to the claim, the topic of the claim, right? So those are called evidences. For example, if I say something with respect to US elections, so all the topics, all the posts that have been talking about this particular topic, I'm trying to get those relevant documents from Wikipedia, from news sources, from WHO, from XYZ places, right? So these are the collection or gathering a collection of evidences in claim tracking. Once we have evidences, the next thing that we can do, we can find a stance towards that evidences. So the statement that we are dealing with, the claim, what its stance with respect to the evidences that we found in the claim tracking part, right? So here you can say that whether a claim, the stance of the claim is supporting, denying, or it's just a query, and different kinds of stuff. So normally stance detection problem classify a statement into four classes, and these are SDQC, that means support, deny, query, and comment. But since we have this claim data, we have already identified the claim detection. So this is more towards the support and denial cases or simple comment cases, right? Query will not be part of it. If you can see that if a question is there, that cannot be claimed. If you assume this statement to be true, then probably in stance detection, you cannot classify as a query. But if your assumption is not that, then probably in stance detection, you also have the fourth class as whether the stance is a query stance or not, right? Is it true that if you something said that something, some plane crash, some event happened, something happened, so people can ask, is it true? So that's kind of the query statement. Now, once we have these stances, we can utilize this information for the finally claim veracity prediction. Now, given all these evidences, given all the instances that we have against these evidences, now can we say that whatever claim we are dealing with, whether it's a true, false, or unverified? So that's again the classification problem. But this veracity needs these evidences or external information, the evidences that we are talking about, right? So the first task after claim detection is claim tracking. I already mentioned briefly mentioned what these are actually. So you start with claim. You know that the claim is your input. So what you can do is that you can monitor the social media channels and you find the post discussing the same topic as the claim you have. So if claim is for, let's say, COVID-19 precautions or COVID-19 symptoms, you try to find the relevant posted which are discussing these. And in order to do so, you have to pre-process this information because you don't want a fake news as an evidence, right? So you want to get only those evidences, those posts which are coming from reliable sources. For example, for COVID-19, you can say that, okay, ICMR or NCI in India or WHO or different government agencies, these are the reliable sources. So if I can detect some, or if I can collect some resources from these sources, then these are evidences for my case. That's the claim tracking part. So it's a collection and then filtering. That's the two part in this claim tracking. The second part of this veracity, as I just mentioned, is the stance classification. So Within this instance classification, for each evidences, you have to determine how host is oriented towards the claim veracity, right? So for example, if you have evidence and a claim, you can go for the either binary score, that means whether it's supporting or denying, or you can go for the four class classification. That means whether it's supporting the claim, the evidences are supporting the claim, or it's a denying, or it's a just a query, or it's a common. Right? So different kind of classification algorithm you can apply for that, right? And this is very famously called as SDQC problem. Right? So using this, and you can get this information. The main purpose of this stance classification is that to assist in the veracity part, right? So itself, SDQC does not stand on its own for the claim verification, rather it gives some input to the veracity part, right? So that's what the importance of this particular task comes into the picture. And finally, we go for the veracity. So this actually deals with the whether whatever claim you have identified, whether it's true or not or unverified. That the three class classification or two class classification that you are doing. So it uses set of post evidence collected in frame tracking component, and it also utilizes the stances label produced by the SDQC problem. So these two it utilize definitely. And additionally, if your veracity, if you want to use additional resources, you can also utilize some other resources. And many work have done this kind of stuff as well. So any combination of this are possible for the veracity prediction. But a general pipeline is this: the claim detection, claim collection of evidences, then instances, and then veracity prediction. That's the pipeline that we have seen in a general sense. All right. So this is the very highlight of this particular claim veracity, or the crux of this veracity. Now let's look at some of the papers which actually try to detect whether the claims are has some veracity or not, whether the claims are credible, not credible, or inconsistent. So in particular, this task, which is in 2017, they assess claims, right, to be credible, not credible, or inconsistent. This is again the same thing, whether the claim is true, not true, or we can't say anything, it's unverified. Now, how they did this particular, how they find this labels is using some subject and some predicate. So they got some OpenAI triples. So tweet content is this: Egypt air flight on fire before crash. This is the claim that you have. So using OpenAI triples, they have got these triplets, which is the first is the event, second is the event, and third is the relationship. Sorry, Egypt air flight is the event, crash is entity, crash is another entity, and on fire is the relationship. So they take this to create a SP tuple, that means subject and predicate tuple. And for subject, they have merged these entities. So Egypt flight MS4840 A04 and crash, it forms a subject, and whatever the relation they got from OpenAI triple, this is the predicate they have. So likewise, they have computed this SP for subject and predicate tuple for every sentence in the dataset. After that, what they did is that they use this SP tuple to collect some evidences from web search results. That means they have queried on the internet and they collected some evidences for this tuples, for this subject specifically. Right? After that, what they did is that whatever evidences they gathered, they tried to create a dependency graph among this SP tuples with respect to the evidences they have. Right? So they got some documents, evidences, and using that evidences, they tried to check whether this and first SP tuple and second SP tuple has some sort of dependency on each other or not. That means whether there is a like this uh, means both are same, or they have giving different information. That's the direct dependency and indirect dependency they computed. So I'll talk about this dependency in a later slide. Now, this is the overall architecture or the overall process that they did. So starting from some major event, again the topic is known to them. So let's say some flight crash investigation going on, and from this they have extracted claims using this subject and predicate. Right? So they're using OpenAI too. They got some extracted claim, and after that they have clustered these subject if they're talking with respect to the same relation. So in the previous here, you can see that the first two sentences is talking, the predicate is on fire. So that means these two tweets should be clustered together. And the third tweet has a different predicate. So this tweet will have separate clustering. So based on that, they did this clustering. So these three tweets belong to one subject predicate pair, and the others are there. Now, in the next step, they utilize this clusters or the subject and predicate tuples to get some evidences from web search, right? So they did some web search, use Google probably, and then get some evidences. Using these evidences, they create this claim dependency graph. So they check all the subject predicate tuples in this particular cluster. What are their dependency? Either they have a direct dependency, which is marked as a green, or they have indirect dependency. And these dependency, that means whether we can conclude, if I know this first SP as a claim true, using that information, if I can conclude that this is also a correct claim, then there is a direct dependency. The information content should be similar, then it is a direct dependency, otherwise it's a indirect. And based on this feature, they have computed the likelihood of credibility. They computed some probability to get the final conclusion. And this step they keep on refining again and again. So this is the iterative process. Now, how to even before that, so how they did this feature computation for the estimation of likelihood? So they use these features. So what is the number of result for each search query that they got from web search engine? Again, they use some lexicon of doubt words, and they check whether what is the fraction of top keywords. And these are the different features that they utilize for the likelihood computation. Similarly, they also use some feature in their ablation study with respect to the tutor specific feature, the metadata of the tutor, and the user profile information from the tutor. So they at the end they showed the comparison with this. Now let's move on the claim dependency. What do we mean by claim dependency? So claim dependency is a direct dependency. Is it if a pair of claim you are considering, then you can say a direct dependency have exists between C1 and C2 if C1 is likely to be credible when C2 deemed credible. So that's the definition for direct dependency. If C1 is credible, you also say, okay, C2 is also credible, and vice versa. For inverse dependency, a pair of claim, if C1 is likely to be credible when C2 is deemed not credible. So it's the opposite case. And this pair dependency is called inverse dependency. And this is what the red arrow was marked. Now, what we can do with this dependency score? So how can we utilize this? Using this dependency score, they did they find what are the relation, what are the likelihood of two claims or claim to be true or false. So they computed the dependency like this. So given two claims with same subject, right? That means they're talking the set of entities in these claims are same in both cases, but they have two different predicates, right? So they draw a dependency, direct dependency graph between two such claims C1 and C2 if the predicate in P1 and predicate in P2 are the synonyms of each other. That's one condition. And the second condition they check is that if the cosine similarity of P1 vector and P2 vector is greater than some threshold, some defined threshold. So if any of these conditions are true, then they say that C1 and C2 have the direct dependency link. That means if you know C1, you can also say, okay, C2 is also credible, right? Similarly, for the indirect dependency, they check whether P1 and P2 are antonym of each other or not. That's one case. And the other case of the cosine similarity, if it is lesser than the threshold tau. Right? So that's, they have created this indirect dependency. Once they have this, they utilize this for the sort of logic to get the likelihood of a claim to be in particular class. So if you have some evidence of claim C1 being a particular class as a credible, non-credible, or unverified, if you have evidence, then you are saying that it is likely that C1 belongs to class. This is just an initial definition. Now, utilizing this evidence definition, what they say that if I know evidence of C1 and C2, and there is a direct relation between C1 and C2, then it's likely that C2 is also belongs to class, that particular class. And the third case is that if the indirect dependency exists between C1 and C2, and I know C1 belongs to class 1, then it's unlikely that C2 will belong to class 2. So that's the three rules they have applied to get the likelihood. And accordingly, they computed probability over uh, all the statements that they have, all the claims they have. Within this, they, since one of the major concern or limitation of this particular work is that they are very, very topic oriented. So they're not generalized. So whatever experiment, whatever methodology they have discussed, it is specific to one particular event. And in total, they have considered or they've collected claims detection and claim veracity data set for 5 major events. So 2 of these events are related to this plane disaster, MS-370 and MS-804. Other 3 are the Panama Papers leak, bombing in Brussels, and assassination of Kim Jong-un. So these 5 events they have collect topics they have considered, and all those tweets which talks about this topic they have gathered that. Right? And this is the result that they have showed. And I mentioned earlier, they, in addition to the WSR based feature, that means for web search result based feature, that doubt class and other thing, they've also utilized tweet based feature. And these tweet based features are very, very generic profile features, follow, number of follows, number of this, etc. And they conclude that rather than using the profile feature, if you use this web search result feature, which is very likely to find whether there's a doubt in the claim or not, it will give you a non-credible story. So that's the analysis they did in their paper. So if you want interested, you can have a look. The main point is that utilizing the traditional tutor-based feature on social media, those features did not give them better result as compared to the WSR result. And if you can see that the results are significant, it's not like that they're gaining slightly. So if you can look at this credible score, they're getting almost more than 10% increment in F4 score, right? In a random, the best they got 86, and here you are getting 70, 75, right? Similarly, for the non-score, it is best they got 0.56 for the extremely randomized, but here they have achieved at least 7% increment using WSR feature. Similarly, you can see for the conclusive part is there. All right, so another work on this claim verification or fact verification is this. This paper comes in 2018, and they uses a very similar approach. And there are actually 2 objectives of this paper. One is that they have to assess veracity of the claim, whether a claim is true or false and unverified. And the second, they also want to retrieve evidences. That's the major part of this particular work. They are not only interested in getting the veracity of the claim, also they're interested in retrieving the evidences. And this particular work is actually part of a workshop called Fever. Give you some hint about that particular. And this task is defined in that particular workshop. Anyway, so moving forward, what they did is it's not very difficult to understand. So very simple thing, especially when a claim is given to them. What they did is that they first got some relevant document using TF-ID vectors comparison. So they extracted some document from Wikipedia, and for that they have used TF-ID vector, the cosine similarity between the TF-ID vector of the claim and the document. They retrieve some of the document, and from this document they also extracted the relevant sentences. So whatever relevant document they got using the first step, they further filter the sentences in those documents by selecting only those sentences which has a high cosine similarity in TF vector space with respect to TF. So at this point, they have a set of sentences which is very relevant coming from the Wikipedia articles. All right, that's the first part. The second part, what they did is that they did some NER, they get some entity from the claim, and they retrieve documents with respect to that event, that named entity only. So if let's say if it is a MH370 plane crash, so they got the document with respect to MH370. And then they use Levenstein distance to get all the sentence present in that. So they chose this documents with respect to this Levenstein distance. After having two sets of sentences, they've concatenated the rest. They've combined all these sentences coming from two different paths, and they say, this is my evidence. This is my evidence. Now, they project the problem of detection or claim verification rather as a textual interment recognition model. So what they say that for each sentence, they calculate the probability of it supporting that claim. Okay. So hypothesis and the premise. So the entailment, right? So one is the claim and another is the evidence. And they compute probability distribution over whether this is a support that is entail, not entail, or unknown. So they using this textual employment recognition model or RT we can call it. So they computed three different probabilities, and based on this probability they further derive some features, and these features are for 12 different specific features they have utilized in this work. So using textual entailment model, they have defined this SI as the probability of support, that a claim is evidence is supporting that claim, or evidence is refuting that claim, or even evidence is inconclusive for the claim. So these three probability they have computed, and based on these probability they have defined 12 features. So first set of features actually the number of evidences. The second is the quantify the number of evidences. That means they use this multiplication and summation multiplied with SI and CSI. And what is CSI? CSI is the number of they're using one if SI is greater than other, the maximum probability is the SI. Otherwise, they're taking it as 0. Similarly, the third set of feature, they compute the degree, like how strongly this sentence is supporting a claim or refuting a claim. And finally, the F1, F10, F11, F12 are the average length of the support of the supporting sentences. So these 12 different features they have used for their purpose. And once they have these features, they run a random forest classifier to detect whether there is a this is a claim, is it true, claim is it false, or it's unverified, the three class that we talk about. And for this they have used this Fever 2018 dataset, which is actually a workshop, and they also have a dataset for them, right? You can, they're publicly release this data set, so you can utilize this. And they use, they got some results, though this is not the best result they got. The baseline was this, and the de facto NLP system, which is their system, they got fever score of 38.5. And this other baseline, this is not exactly the one system, they are different systems. All right. So moving forward, and this is one of the recent work. It has been published in ACL 2020, and this is a decision-based co-attention network for explainable claim verification. Another thing which is uh, crucial here is that they are not only interested in detecting the veracity of the claim or the fact, they are also interested in the explainable claim verification. So which section of the which evidences is actually contributing towards the claim. And for that, they utilize this decision tree based evidence model. So they use two sub modules. One is DTE, another is co-attention self network. So I'll talk each of these in not in too much detail, but slightly in detail. All right. So first of all, they have defined three decision conditions for the DT model. Right? So the three conditions are this, or let me give you the structure of the data first. So the structure of the data is like this. So you have a claim C, right? And for this claim on social media site, you have nested replies, you have conversation history. So R1 and R11 and R1N are the replies directly to this claim, and R21 is a reply to R1. So this R21 is not a direct reply to claim, rather it's a nested reply to R11. And this way, this hierarchy is built. And this is actually representing the kind of data, kind of structured data they are dealing with. Right? Now, what they did is that, so one of the major thing that they are looking for is to explainability. That means in order to get the veracity of this claim, which of these responses are actually relevant for establishing that claim. That means if I say at the end this claim is a true claim, that means it's the correct claim. So which of these replies actually has a higher relevance with that veracity? So that's the objective is that. So first, they define these three decision conditions in order to select the relevant replies from these three comments. So using these three conditions, they say, okay, I'll only select R1L, R22, RK2, and rest of the comments are not important. They are just a noise. Right? So for establishing the veracity of a claim, only these set of replies or these set of responses are sufficient. So the first decision condition is simple semantic correlation and semantic similarity between comments and claim, right? And this is the X1. That's a condition I'm just denoting as X1. Right? The second is the credibility of the reviewers. So the person who posted this particular claim or the tweet, what is the credibility of that review? So for credibility, they have considered these features. So whether the account is verified or not, whether there is a geolocation is there or not, skin name is there, like this, right? So profile image, how many followers are there, friends are there, favorites, and based on this criterion, they have given some credibility scores, right? The third condition is credibility of comments, right? And this, they try to check what is the credibility of each comment. And for that, they've used this elements and these criteria. So again, the whether geolocation is mentioned or not, there is some source or not, and likewise different elements are there. And for each, what is the criterion, and accordingly, what is the credibility score they can assign to a particular comment. And finally, they sum everything up to come as a X3. Now, once they have X1, X2, and X3, for every node in this tree comment, they computed this. So they check whether x1 is less than a2. So x1 you get from the semantic similarity, and sorry, this should be a1. So a1, a2, a3 are the threshold value, and they've fixed on their own, and right. So these are the threshold value that they have predefined in initial case, and also they have give some idea how to compute this, how to optimize this threshold value as well. So what they did is that at this particular R1, they take a decision tree. So if X1 is less than A2, then yes, this particular tweet is relevant for the claim. If it is not, then check for X2. That means what is the credibility of the reviewer? If reviewer is credible, that means the person who posted this comment is credible, then yes, we can include this particular comment for our consideration. If not, what is the credibility of the comment? So they check that. So this is the decision tree they use to get the
Please give
select the.
example of the threshold and how it is computed.
So these are initially they have computed, they have just fixed this threshold, and then they have optimized it using a training. I'm coming to that. So this is just one module of this the entire network, right? So this is just selecting a particular comment for establishing the veracity of the claim. And why they are doing this, you can easily see here. So if this is a tree comment and I'm selecting R1L, R22 and RK2, that means I am also giving evidences for the veracity. That means it is somehow explaining that this particular reply is actually important or evidence for the veracity. That's the information they're trying to get from this DT module. The next module is the DTC, the entire co-attention network. And you can see here is that this is the DT model at the end, right? And I'll talk about that how to find this attention, this threshold. So basically that threshold is based on this optimization. So everything that they get from here, they propagate it back to the network. And additionally they have also used one model which is not shown here to get those threshold value. They adjusted those threshold value based on the whatever the score or error loss function they are getting at the top. But probably that is not very important. So they optimize, they can also optimize based on empirical evidences. That means they they also mentioned this, they tried different threshold values as well. Okay. So whatever the comment they have selected from this tree comment, they fed some LSTM structures for the sequence reply comment, and also they did for the claim that is made. That's the root node. And they computed two self-attention module. One is with respect to this query, which is coming from the claim, and this self-attention is computed with respect to the context that we have. And finally, when they fuse these two information, this is the evidence part, right? Because these are the evidences they are taking, and this is the actually claim. In order to fuse, again, there are lots of possibilities that are there. You can use that. So one simple possibility is that you can just concatenate these two representation together. That means you take E and C together. But in this work, what they did, they have used this dot product as well as the differences. So they clubbed everything together and they fed into the softmax for the classification of whether this particular claim, given these evidences, are verifiable, it's a true or false. So that's the co-attention network, the entire network they have proposed. And obviously all the weights, all the attentions or values, they will be tuned during the training process. As part of the results, so the data set that they use is the Rimmer eval data set, and there's another FEAM data set, that two data set that they have used. Right? And these are the statistics of these data set with respect to number of posts, number of comments, and like that, right? And distribution as a training, validation, and testing. And they also compared their model with respect to various baseline, SVM baseline, CNN, textual entailment, and different baseline, right? And our last row is their own model. So you can see that in both this data set, they got decent accuracy, right? So for this, they are achieve almost 3% increment. This they are 2.5% increment in this case, as a F1 score is concerned. And additionally, they got improvement in the result section. Additionally, they also can explain. So this is the tree structure that they have taken for one of the tree. So this is the root node of the tree comment tree, right? Where the root is the claim. So 10 people have died in a shooting and this, right? So that's the claim. And these are the comment hierarchies. This is a conversation tree, right? People are doing that. Now you can clearly see these are the highlighted arrows, the red arrows. These are the comments which were selected through DT process. Right? The three decision criteria X1, X2, X3 was used, and using decision tree, this particular paper, this particular method actually find that this comment is relevant, this comment is relevant, but this comment is not relevant, and this comment is not relevant, and this comment is not relevant. So whenever you can see this red arrow here, 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 these are actually relevant with respect to this claim. All others are irrelevant. For example, you can just look at this. Sky News, why are you shocked? So this reply is does not give any information for establishing the veracity of this particular claim as a true and false. Right? So that's the benefit they get from this DT part. Right? So they got better result and they also get better explainability quality capability. Right? And this is very recent paper. It's a just ACL 2020 paper, right? So that's the most recent paper we found out on this claim verification. All right, so this slides actually show some of the relevant data set that are available for this claim verification part. So there is one, this fever data set, one of the paper we discussed about that. Another SkyFat data set, which is basically the content is scientific claims. The next is a FEAM dataset, which has 9 incidents called Charlie Hebdo shooting. And this is actually that Rue Marieval. This is very close to Rue Marieval. Same structure. Some events are there and some conversation tweets are there. Another is PolitiFact, which has content from politics. Snoop's dataset, which has some good amount of incidents. But again, the number of samples that you can see in this, right? So they are not very the topics are very diverse, and they talk about any particular domain. So all these data set, which is the main issue with claim or fake news detection, is that the information, the domain information is very much required. If you want to if your model is trained on PolitiFact and you want to use it on sci-fi, then definitely it's going to crash, right? So this only handles the scientific claims, this handles the political related things, and different stuffs are there. And these are the output classes for each of these. So in for fever, you have 3 classes. In this, you have 2. FEAM has only 2. And this within PolitiFact, there are more numbers, I think 6 or 7 claims. So false, half true, true, mostly true. So these kind of different labels you have, right? So that's the different relevant data sets you can look into. And also there are other data set as well, but the main thing is that in order to generate these data sets, it's very difficult. You have to find the news and you have to find evidences, right? So it's very unlikely that you can do it in a silver mode, like in automated mode. You have to have some human intervention required in order to verify whether this particular claim is verified or not, in order to create data set. Once you have data set, probably you can go for the some deep learning model or some other model that we discussed. Now, so coming to the last couple of slides of my talk here is that, so let's talk about some of the shortcomings of the field, right? So one major thing that we have found out that, especially with respect to the claim detection, is that most of the claim detection approaches works with the structured or semi-structured text, most of them. and very few work are on the client's noisy data set, such as Twitter and some other stuff. Some works are there, but they are on very preliminary state. So there is lots of scopes that we can do our research and progress this field with respect to noisy text, right? Another thing that you can see that with respect to the claim detection, especially some of the work you try to utilize the structure of the text, right? But these steps are very naive or very simple. So we can think of utilizing the dependency tree, utilizing the consistency tree in a slightly better way. So that area can also be explored, and there are some works which are actually doing this, right? The third is that in order to veracity problem, you need lots of evidences. So maybe you can look for some knowledge or source specific domain or knowledge, source specific knowledge graph, which can act as the evidence for establishing the veracity of claim. So in that respect, you can have the future guidelines would be, we can work with some noisy data sets. Some of the data sets are already available. Clef is there, some theme data set is there, but everything is with respect to some domain, right? Similarly, you can, I just talked about, you can think of incorporating some structure information. We can think of generalized knowledge base and knowledge graph. So this, most of the work or some of the work exists today, they particularly talk about some particular domain and some particular knowledge base. Can we think of a generalized knowledge graph on that, right? So such that if any future event, new event comes into the picture, which our system should not fail. For example, this year we have seen COVID. So if we could have, like, if we had this generalized knowledge base, probably the COVID related fake news information, we would be we would have handled it more efficiently, right? So by this slide, I'm concluding my talk. And these are some of the references, some papers that we have discussed, referred. And finally, thanks. Yes, if you have any question, I'd be happy to take that. Thank you.
Thank you, Dr. Prakash. Nice slide. Any questions, comments from the audience?
All right, so if there are no other questions, we can stop
So,
here. And yeah,
so thank you, sir, for your great tutorial on fake news and claim detection. Now we will again meet at sharp 12:45 p.m. for the next part of this tutorial. As Tanmoy sir said earlier, we will take 30 minutes of break.
thank you.
So we'll meet at 12:45, or you want me to continue?
Sir, it's totally up to you.
So let me ask the audience, of what do you suggest? Should we take a break of say 15 to 20 minutes and then we resume?
Yes, sir, it would be good if we can take a break for
Okay, perfect. So let's meet at 12:45 sharp. Okay, thank you.
Okay,
Thank
okay.
you.